This is Senior Algebra, Section 2.5, Applications of Geometric Formulas. Today, we're looking at formulas for geometry, some applied problems, vertical straight angles, and some solving of formulas. So we have some general formulas that we've seen in geometry here. We talk about some different angles here. We say adjacent angles, they're next to each other, they share a side there. So those two angles would be considered adjacent. Complementary angles. And when we think of complementary, a complementary roll is a smaller roll. It is the smaller of the two. That two angles whose sum is 90. Sometimes we see them like that with the 1 and the 2 on the right side. Other times they don't have to be next to each other. We also have supplementary angles. Supplementary, when you take a supplement, take it to get bigger, stronger, that type of stuff. It's the bigger one of the two. They add to 180. Sometimes we'll see them like that with that are called a linear pair. Other times they'll not be next to each other, but they are still considered supplementary. A linear pair says two adjacent angles. We talked about adjacent. They share that side, and they have to be next to each other. They make a straight line, so they should add up to 180 degrees. There's my straight line, 180 degrees. There's my adjacent side, so they have an angle there. And they add up to 180 when I add the two angles there. Vertical angles. Vertical angles are across from each other. They share a vertex and two rays there, or two lines. So we have the ray there, they make lines there. So angle 1 and angle 3 are considered vertical. Angle 4 and angle 2 are vertical as well. Angle bisector. To bisect means to cut in half and cut in two equal pieces. So angle 1 and angle 2 have the same measure. On the next page, we have some formulas as well. Some area formulas, rectangle, squares, triangle, parallelogram. The one we'll look at today in the example is a parallelogram. A couple different ways to write that, and we'll see that in the example here. We have some volume ones as well. We don't necessarily need them right away, but we may eventually here. So in example 1, it says a trapezoid has an area of 210 square feet. The height is 10 feet larger, and the larger base is 27 feet. We want to find the other base here. So we go back to our formula. Our formula is that area of a trapezoid equals 1/2 base 1 plus base 2 times the height. Notice I put the h on the end. Doesn't matter. Okay, because I'm multiplying 1/2 times what it's in parentheses times the height. And actually, we'll end up moving the height back over in a second here. So I start to fill in what I know. I know the area is 210, base 1, that'll be our unknown, but we know base 2 is 27 feet. The height, 10. At this point, I'm going to take the 210 on the left-hand side, but I'm going to simplify the right. So I'm going to take the 10 and the 1/2, and I'm going to multiply those together. So 10 times 1/2 is 5. So I'm going to write it as 5 times the quantity B1 plus 27. At this point, I have two options. I could divide by 5 on each side, or I could distribute. Doesn't matter, either one is fine. I'm going to distribute in this case. I get 5 times B1 plus 27 times 5 is 135. When I subtract 135 from each side, I'm going to get 5B1 equals 75. There's a 75. So we're going to solve it up here. 75 equals 5b. I divide each side by 5. b is 15. I check it, I plug it back in, so 15 plus 27, that's 42. 42 times 10 times 1/2 does give me my 210, which I should get on the left-hand side. I should label this, so I'm going to say it's 15. Are we in feet, meters? Looks like, no, we're in feet here. So I'm going to say it is 15 feet. In example 2, it says the backyard is in the shape of a rectangle enclosed with a fence on 3 sides that measures 95 meters around. So we draw our house. A lot of these pictures will help kind of crystallize what's happened here, what's happening. So I have the back door, the windows, and here's my fence. Notice it says that the horizontal length is 5 less than twice the depth. So I have the horizontal length going left to right. The depth, okay, is going back. It says I don't know what the depth is, so we'll talk about that in a second. But what do I do know? The three sides measure 95 meters. So side 1 plus side 2 plus side 3 is 95 meters. How do I label each side now? Well, horizontal length, 5 less than twice the depth. Do I know the depth? No. So that's going to be my x. That's going to be my variable here. So the depth is x on the left side and on the right side. Then says the horizontal length is 5 less than twice the depth. Okay, so this is where we do our translate again. 5 less than twice the depth. Twice the depth, 2x minus 5. So I'm going to take side 1 plus side 2 plus side 3 equals 95. Combine like terms, 2x, x, that gives me 4x minus 5 equals 95. And when I add 5 to both sides, I get 4x equals 100. When I divide each side by 4, x equals 25. So what am I trying to find here? It says I want to find the dimensions of the yard. So I want to find the length and the width, or the depth and the horizontal length here. So if x is 25 on this side, the other side is going to be 25 as well. I need to find the other side here. So I'm going to put 25 at the bottom in for x there. So I have 25 times 2 minus 5. So 25 times 2 is 50. 50 minus 5 is 45 feet. No, we're in meters here. So that's going to be 45 meters here. I'm going to take a second, write a sentence about it. The yard has dimensions of 25 meters by 45 meters, something like that. In example 3, now we have some straight geometry problems here. It says at the right angle, 8 is that, angle 6 is that. So what kind of angles are 6 and 8? We look, they're across from each other, so we consider those vertical angles. They ask us to find y. What do we know about vertical angles? They are equal. So I set the two angles equal to each other. I distribute, I get 6x plus 8 equals 2y plus 68. At this point I have I have y's on both sides, so I'm going to move my y's over to one side, my constants over to the other. When I subtract 8 from each side, I have 2y plus 60 equals 6y. Subtract 2y from each side, I get 4y equals 60. And when I divide each side by 4, just up here because I'm running out of room, y is going to be 15. So great, I found y. What does it ask me to find here? All right, yep, that's y. In C, it asked me to find angle 7 and angle 5. So C and D, they ask us to find those two. Well, in order to do that, I'm going to actually have to find what the actual measure is of angle 6 or 8, either one. In this case, I'll choose that angle there. So angle 6 is 2 times y plus 34. We know y is 15. So 15 plus 34 is 49. 49 times 2 is 98. So we have 98 degrees there. Now, I would argue that the picture doesn't exactly do us justice here, being a 98 degree angle, but if I look back at the math, Nope, everything is correct. So it's just not a great picture here. Now, what do I know about angle 7 and the other angle that we found, that 98 degrees? I know that they add to 180 degrees. They are a linear pair. They create a line. So angle 6 plus angle 7 is 180. We know that angle 6 is 98 degrees. So when I take 180 minus 98 degrees, I'm going to find my angle 7. So angle 7 is 82 degrees there. Angle 5. Okay, angle 5 is right across from angle 7. They are vertical, so they are going to be the same. That's at 82 as well. Our last example, example 4 here, it says, what's the relationship between the two angles? So they are a linear pair. When I put them together, they make a line. They have an adjacent side, their side that's common between them, and they make a line here. So what do we know about a linear pair? They add to 180 degrees because a straight line is 180. So I want to find the measure of the smaller angle. Well, if they add to 180, I know that angle 1 plus angle 2 is 180 degrees. I'll label it angle 1 and angle 2 there. It doesn't really matter here. But I do know that they do add to 180. So I'm going to plug those in. 4x plus 6 plus 11x minus 6 equals 180. Solving it, 4x plus 11x is 15x. The 6's drop out, 6 and negative 6 drop out. So I have 15x equals 180. When I divide each by 15, well, I know 15... if I multiply it by 10, I get 150, so 2 more than that would be another 30, so it's going to be 12. All right, what did I actually want to find here? So I found x. Where do we go from here? I wanted to find the measure of the smaller angle. The smaller angle is angle 1 there, so 4x plus 6, 4 times 12 plus 6, 4 and 12 is 48. 48 plus 6 gives us a measure of 54 degrees, I believe, if my math is correct, which it is in this case. So the sentence I would write something like, the smaller angle has a measure of 54 degrees. Oops, I lied. Wrong one. We got one more example here. Just a bonus. So example 5, we have f equals 9/5 c plus 32. Looking at this, we're going to solve for c. This is our Fahrenheit Celsius conversion here. So I want to get c alone. That means I'm going to move the 32 over first. When I have it, I have f minus 32 on the left-hand side. The right-hand side, I have 9/5 c here. So at this point, I want to get rid of the 9/5. I don't want to divide here, so I don't want to have to divide by a fraction. So how do I get rid of the 9/5? Well, I multiply by the reciprocal. So I'm just going to give myself a little bit more room here. So I'm going to multiply by 5/9 to the right-hand side. Remember, a number times its reciprocal is 1 here. So if I do it to one side, I have to do it to the other, and I have to do it to everything on that side. That's why I put parentheses around the whole thing. 5/9 times 9/5, that just gives me 45 over 45, which is 1 here. So I have a c on the right-hand side. On the left-hand side, I have 5/9 times the quantity, f minus 32. I can leave it like that. I don't have to distribute at all.